Hello everyone. We're going to talk a little bit about metrology. What is metrology? Metrology is the science of measurement. Metrology can be divided depending on the quantity to be measured, examples being time, length, temperature, weight, and more. So what we're saying here is that metrology is the science of measurement in which we divide that up into individual units. Take time, for example. We will divide time into seconds, hours, days, months. Those are that's how we're dividing the time. And those are the units we're using. Length, for example, it could be divided up into inches, feet, millimeters, centimeters, meters, miles. Temperature, it can be divided up into degrees Fahrenheit, degrees Celsius. Weight, it may be divided into ounces, pounds, kilograms, and more. The main concerns in metrology are establishing units of measurement. Like we was talking a minute ago, length, a 1/2 inch. The unit of measurement would be the inch. A foot would be a unit of measurement. Ensuring the uniformity of measurements. So we need to ensure that if I take a measurement and I say it's 3 feet, you take a measurement and you say that exact same distance was 2.5 feet, that's not uniform. Developing methods of measurement. So there are multiple ways we can measure sometimes the same items. There are different methods. We may measure something with a micrometer. We may measure something with a caliper. We may measure something with a tape measure. And it all depends on how precise we need to be with our measurement to determine what type of instrument we're going to use. So errors of measurement. How accurate do we need to be? Where does our accuracy need to lie? Accuracy of measuring instruments and their care. So if I need something to be precise within 0.010 of an inch, I'm not going to use a tape measure. At that point, I'm probably going to use a micrometer or a caliper. If I need something to be accurate, give or take an 1/8 inch, I'm probably going to pull out a tape. Industrial inspection. So what that's talking about is CMMs, or different types of, and there's more than that, ferro arms. There's all kinds of different devices out there that in the industrial, in a manufacturing setting, we use these devices to take precision measurements to make sure that our products are within a certain specification. Objectives of metrology. Provide the required accuracy at a minimum cost. Complete evaluation of newly developed products. Determination of process capabilities. That'll go hand in hand with our quality control class. Determination of measurement instrument capabilities. Minimizing the cost of inspection. Reducing cost of rejection and rework through application of statistical quality control techniques. That also will go hand in hand with our quality control class. To standardize measuring methods. We have to have a standard. We all have to be on the same playing field when it comes to making these precise measurements. If there are no standards, and I say that my measurement's a foot, and you say that your measurement's 1.5 feet, but we're measuring the same product, who's to say who's right? So we have to have a standard set forth saying that this is the standard foot, 12 inches, that's the standard foot. Maintain the accuracy of measurements. To prepare designs for all gauges and special inspection features. Missed one. Process of measurement. The sequence of operations necessary for the execution of measurement is called process of measurement. There are 3 important elements. Measurand, which is the physical quantity intended to be measured, such as length, angle, diameter, or thickness. So in this situation right here, we are talking about measuring the side of this cube. So the physical quantity intended to be measured, such as length, angle, diameter, or thickness, the measurand would be the length of the sidewall of this cube. Reference, physical quantity or property to which quantity comparisons are made. So how are we going to reference the measurement? It would be referenced with, in this situation, we're going to say a tape measure. We're going to reference the side of this cube to a measurement on a tape. Comparators means comparing measurand with some reference. So in this instance, if we are measuring this corner of this cube, let's say for instance it is 4 inches. 4 inches would be our comparator, these inch marks. So, and there would be 4 of them because it's a 4-inch cube. Methods of measurement. There are direct and indirect methods of measurement. A direct method of measurement is a simple method of measurement in which the value of the quantity to be measured is obtained directly without calculations. Method is most widely used in production and is not very accurate because it depends on human judgment. We all make errors, and you have to factor in the human error side of things, especially when we're talking about really precise measurement down to the 10th or down to even the thousandth. Sometimes it'd be very hard for us to be very accurate because of that margin of error that we're used to. Examples of this method of measurement would be rules, vernier calipers, and micrometers. The indirect methods of measurement, the value quantity measured is obtained by measuring other quantities which are functionally related to a required value. Example would be measuring an angle with the use of a sine bar. So right here is a sine bar, and what they're doing right here is they're measuring a specific angle. Sometimes you'll do that to get different heights of things or to measure specific angles on a part. Elements of measuring systems. So standard, the basic element that we must start with, we must have a standard to measure against. Workpiece. Once the standard is chosen, we pick a workpiece. So what are we going to measure? The instrument. With the standard and the workpiece chosen, we determine the type of instrument that would best suit our needs for specific measurements. Person. There must be some form of person or mechanism to perform the measurement. Environment. The measurement must be performed under standard environments. The environment must be considered when taking precision measurements. I want to touch a little bit on the environment part of that. Let's say, for example, you're trying to do a very precise measurement of a block of steel. And you measure that block of steel in a building that's 100 degrees. It gives you a reading of 1.2 inches, 1.250. And somehow that block gets introduced to the outside air, ambient temperature, somewhere around 10 degrees Fahrenheit. You measure that block again. Surprisingly, it's not 1.250 anymore. It may be 1.248 because the environment had made a difference on the size of your workpiece, and that is going to give you a difference in your reading. So we have to pay attention to some things like that. Why, or pay attention to the temperature and maybe dust, some kind of particles on the workpiece when it comes to precision measurement. Fractional units of length. So I'm going to spend a little bit of time in the first week or so of class making sure we can all read a tape measure accurately and efficiently. Because in today's time, that's something that I think gets forgotten, and not always do students come through high school understanding how to read a tape measure. So this specific measurement right here, we have an inch that's blew up, and we've broken that inch into 16 parts. So each of those little, I'm going to call it tick marks, just for lack of better words, are a 1/16 of an inch. So if you count every tick mark between the 1 and the 0, there's going to be 16. It's going to be divided into 16 equal parts. Now if you'll look at the tick marks that are slightly larger, starting with the 1/8 inch one. It'd be the 2/16, which is an 1/8 inch. These are all 1/8 inch. So we have 1/8, 2/8, 3/8, 4/8, 5, 6, 7, and 8. So we've also divided this inch into eighths. And if you notice a minute ago, I said 2/8 right here, right? I said 4/8 right here. That is not an accurate measurement because 2/8 can be reduced down to 1/4 inch. So if I'm looking at this tape measure right now, I'm understanding it's broke up into 8 equal parts, 16 equal parts, and we've also broken this tape measure up into 4 equal parts and 2. But the 4 equal parts is 1/4 inch, 1/2 inch, 3/4 of an inch, and an inch. That's pretty simple, right? If we go directly halfway between the 0 and the 1, that's a 1/2 inch. If we go directly halfway in between the 0 and the 1/2 inch, that's 1/4 of an inch. I mean, if you divide $1 up by 4, you're going to have 4 quarters, right? So if you have 2 quarters, you got 50 cents, same as a 1/2 inch. But what a lot of people, they do pretty good with the quarters, the halves, the 3/4, and the whole number, the 1. But where they struggle is when we get down into the 16ths. What they don't understand is that if you just count these tick marks, you got 3 tick marks over, that's 3/16. If you get to the 5th one, that's 5/16. The 6th one, 6/16, but that can be broken down into an 1/8. So that's a 3/8. So it's a little confusing for people to understand that you're just taking that 1 inch and you're dividing that up into 16 equal parts, or to 8 equal parts, or to 4 equal parts, or 2 equal parts. So going from the left to the right, starting at 0, we have a 1/16 of an inch, an 1/8 inch, 3/16 of an inch, 1/4 inch, 5/16 of an inch, 3/8, 7/16 of an inch, 1/2 of an inch, 9/16 of an inch, 5/8 of an inch, 11/16 of an inch, 3/4, 13/16 of an inch, 7/8, 15/16 of an inch, and then 1 inch. Now, if I hand you a tape measure and I'm wanting you to measure something and it's the distance from the 0 to this 15/16 here, but you don't know that it's 15/16, I don't expect you to come here and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15/16. You understand that this 1 inch as a whole, is 16/16 of an inch. So if we step back one of those, we're going to know that that's 15/16 of an inch. Now we understand that these slightly larger lines are all 1/8 inch lines, right? Equally divided into 8 parts. If whatever we're measuring comes all the way out here to right here, instead of us counting 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, we're going to know that there is 8 equally divided up parts, and if we step back one of those, that's going to be 7/8, so it's 7/8 of an inch. So this is something that with a little bit of practice anybody could get good at. You can look at a tape measure and just rack off a number. You know, if I say, what's this? You could say 11/16. What's this? That's a 1/2 inch. What's this? That's 1/4 inch. What's that? That's an 1/8 inch. That's pretty easy to do, but it takes a little practice. You have to understand that if you have 2/16, that is actually an 1/8 of an inch. Or if you have 2/8, that would be considered a 1/4 of an inch. Now, to break that down a little bit more, we're going to look at taking the fractions to a decimal. So the same picture we had a minute ago with 1/16 of an inch, that can also mean something else. 1/2 may be written down as 0.5. If you look at it here, I kind of wrote down a few different conversions, and it's as simple as taking the 1 and dividing it by 16, and you get 0.0625. So if you hear somebody give a measurement of 0.375, you know that's a typical 3/8 of an inch. If you hear somebody say something like 0.75, that should automatically in your head come up to you as 0.75. If I was to say 0.625 or 625 thousandths, I'll talk about that in a minute, that would be 5/8 of an inch. So just understanding the decimals, the decimal system, understanding fractions, fractional units of length, like breaking an inch down into 16 parts, even to 32 parts or 64 parts, you know. But that's very important when it comes to metrology, and even more important is understanding that 0.250 is a 1/4 inch. 0.125 is an 1/8 inch. And like I said earlier, that's as simple as saying 1 divided by 8 equals 0.125. Now what is 0.125? So let's look at some common terminology here. 0.001. When you're in math class, I'm sure in middle school, grade school, maybe even high school, at some point in time, they taught you that 3 spaces past the decimal point is 1/1000ths. And they taught you that 2 spaces past the decimal point, this one right here, would be 100th. This would be 1/10. I'm not saying they're wrong. For all purposes that they're teaching you, they're right. But for metrology, terminology, machining, that sort of thing, it's a little different. What we have here is 1/1000th of an inch, or 1/thou. That's some slang terminology that you would hear used in manufacturing trade or the machinist trade. So what would this be? I bet you're thinking that's 1/10 of an inch. And it is 1/10 of an inch. But according to most machinists, and well, actually probably all machinists, and most people that you'll come across in manufacturing, that's actually 100,000ths of an inch, or 100 thou. So what would this be considered? 0.010. You can email your answer to me at gsmith0098@kctcs.edu. Or this, 0.0005. This would be considered 1/2 thou or 5/10. Anything below 1/1000 of an below 1 decimal point below 1/1000th of an inch is considered 1/10 of 1/1000. So if you have a 0.0007, that would be 7/10. And we're talking about a very precise measurement there. So that's 7/10 of 1/1000th of an inch. If you get down to that small of a measurement, you really got to know what you're doing when you get into tenths, and to try to be able to be accurate at that level. Most people are not going to be. But that's just a little bit of an introduction on metrology, and I wanted to throw a little bit out there about measurements and hundredths, thousandths, that sort of thing. That's hard for people to understand, because a lot of people will look at this number right here and they'll want to say that's a 1/10 of an inch, which it is. But whenever we're talking in class, we're going to consider that 100,000ths of an inch, because we want to be precise down to 1/1000th of an inch. That's what most things go by whenever, that's common terminology when it comes to machining and manufacturing. So just kind of bring a little bit of this knowledge that you've gained through this video to class with you, and we'll put it into a better perspective in lab.